Let's learn in this video how to use a stateful set in a Kubernetes cluster to deploy stateful applications like for a database. When we want to deploy a pod into a Kubernetes cluster, we have mainly four options at least. First, simplest option is to deploy a simple pod object into the cluster. A pod is not backed by a scale set, so it's not really recommended. It's only good for troubleshooting. Because if you lose that pod, then there will not be any object that will go to retrieve or recreate that pod automatically for us. The second option would be to create a daemon set. Daemon set is an object in Kubernetes that will go to deploy one or multiple pods in each node of the cluster. This is useful for pods that will go to collect logs and metrics, or that will go to do network policies inside your cluster. Third option would be to use the deployment object. And this object is very interesting because it allows you to create a number of replica that will be deployed in the nodes of your cluster, and it can go to scale out and scale down using the HPA, horizontal pod autoscaler. And that's one of the most used objects inside the Kubernetes cluster. But we have a fourth type, which is a stateful set. A stateful set is like a deployment. It creates a number of replica for the pods, but it has some specific features for the stateful set. Like, for example, when we scale out a stateful set, it will go to scale out the number of the replica, but it will go also to scale out the persistent volumes. Let's see a comparison between the two. So for a deployment, if we create a deployment and we map or we mount a volume into the deployment, then that means all the pods, they will consume the same persistent volume using the same persistent volume claim. But however, within a stateful set, it will be different. So if you go to scale, let's say 3 replica for the pods, then you would have 3 pods running, but each pod will have its own persistent volume and persistent volume claim and its own storage. They will not share the same storage as with the deployment. So that's one difference. A second difference is that each one of these pods will have its own network identity, and that will allow us to go to connect using the DNS service name to the pod number 1 or the pod number 2 or pod number 3. Imagine here that you have a database that is using replication, for example, where you have the master slave or the primary and secondary data, or the main one is for read write and multiple replica for read only instances. So if you want to access those instances, then you would be able to do that using the stateful set, where you would have the DNS name for each one of the pods. So when we see a pod here, is not just a replica like with the deployment. A pod is stateful here, but the pod here will be a reference, or will give you access to the persistent volume behind, or to the database that is hosted in here. So we might imagine here that we have main replica, or the main database right here, and many replica for read only available right here. So if I want to access the read only number 1 or number 2, then I will be using those DNS names. Let's see how we can create a stateful set. So here we see the definition for a stateful set. I put here a sample definition. So here it's a pod that will go to deploy a MS SQL Server, Microsoft SQL Server database. So I create the kind stateful set, and then as with the deployment, it would have a name, it would have a number of replica, in this case it's 1, but it would have also some specific features here, like the service name. So this is the service that will be used to point or to get access to the stateful set, and that service should be headless. Headless service means it would have the node IP equal to none. And then here, instead, because this is a database, so we need storage. So instead of using persistent volume claims, here we are using the volume claim templates. So note here, we are creating that template, specifying the storage class name inside that template. Here I'm using managed CSI, for example. You can use the default one. This one going to create an Azure disk for me with a capacity of 1 GB of storage, and that's going to be accessible using the read write once mode. It means only pods from within the same node can access that Azure disk. And then I go to mount that into my containers. So note here, for each container, I mount that volume referencing to data, but here I have only one replica, so it means one persistent volume claim will be created. But if I have here 2 or 3 replica, then because this is a template, it will go to create multiple persistent volume claims for me. It will create multiple disks, and for each pod, it will go to mount one dedicated persistent volume. So for 3 pods, it will go to create 3 disks. Each disk will be mounted into a dedicated volume. And then we have some other attributes that you might know from the deployment for managing the persistent volume claim retention policy. When the pod is deleted, I want to delete the persistent volume, or when it's scaled, I want also to delete it. And then specifying the security context, the host name, the termination grace period seconds to wait for 13 seconds, for example, for 30 seconds before going to delete the pod itself. Great, let's now take a look to a demo right here. So all the scripts, the YAML files that I'll be using in this demo are available on this GitHub repository. So if you go take a look here, you'll find it very well documented, where you would have that README file right here. I have downloaded it into VS Code, and here I can see my objects, which are going to be service and Statefulset. So what I am trying to do here is that I will go to deploy 4 objects. First 2 objects I'm going to deploy are the Statefulset, which will back a database. So here I want to have a web application that is accessing a SQL Server database using the Statefulset. So for that, I first go to create the Statefulset right here, using the attributes as we have seen it. So I give a name to that Statefulset, specify the service name, and that's the service name we'll explore right here. It should use the same service name right here. And that service name, as we have said, it's a little bit specific. It's special because it have here the cluster IP equal to none. And this is what is called the headless service that is typically used with the Statefulset to give access to the pods within the Statefulset. So it will not do that load balancing, that default load balancing. It will go to straight to give us access to one of the pods within the Statefulset. Then I specify number of replica of 1. We'll start with 1, but later we'll go to scale this out to 3 replica, and we'll see what will happen and how things will change. Then I specify the retention policy. You can change that if you want to, and then specifying the host name, the FS security group for MS SQL server, and then specifying the image here from MCR. So this is the image using SQL Server 2022 deployed into an Ubuntu machine 2004. And then for SQL Server, I'll expose the port number 1433, which is the default port number. And then I'm using some environment variables to accept the terms of the contract, specifying a password, and this is the password I'll use to access that SQL Server database. And then I'm using here the developer instance for a SQL Server. And then because that SQL Server will use a database, so I'll go to deploy, or I'll go to save that database into an Azure disk. For that here, I'll go to mount a volume, name it data, and I'll mount it on the volume or on the path var opt MS SQL, which is the default path used by SQL Server. And then here I go to mount that volume using persistent volume claim, but here again I'm using a template because I'm inside a Statefulset. So within that template I specify here the metadata, the name of this template, which is data, that will be mounted right here. And then for the access mode, I want to use it for read write once. It means only pods from the same node can access this persistent volume. And then I want to request 1 GB of storage, and the storage class I want to use to provision this persistent volume is the managed CSI, which is defined by default in AKS, that will go to provision an Azure disk that uses the CSI feature right here. So this is my stateful set. I'll go to expose it using the headless service with type cluster IP and that have cluster IP equal to none. Let's see now from my application. So here I have created a deployment. So this is going to be like my front-end application that will go to connect to the database, for example, or to the stateful set. So it have a name, and it's using here an image that I have created and push it into Docker Hub. That image will go to try to connect to that stateful set using the connection string. So not here, the connection string, I'm specifying here the server equal, and then I put here the name of the stateful set service that is exposed, which is MS SQL service right here. And then I put the name of the database to be created, the password, not here, it's the same password I'm using, and the environment variable for my SQL server, and then encrypt equal false. And then I want to expose this service using a load balancer. Of course, best practice here would be to use the ingress controller in order to expose securely your services with TLS. But here for the demo, let's do it like this. And also for exposing the password, it's better to use the secret objects or to use an external KMS solution like Azure Key Vault to secure the secrets from here. So let's go to deploy this sample application. So here from the console, I'm already connected to my AKS cluster. If I do get nodes, I see the 3 nodes from my cluster. And here I go to deploy the files. So I'll deploy the 2 files, the YAML files. So that will go to create the deployment for me, the service for the deployment, the SQL service stateful set, and the service bucket. Let's go now to get the objects that were created out of this. So let's get the stateful set, the pods, the services, and the PV and the PVC. So here we can see the stateful set is created. We have one because we have requested one single replica, and then that stateful set will have a name. Not here the name, it doesn't have a generated ID like with the deployment, like with the web app deployment right here. It have a name or an index that will start with 0, then the second one is 1, 2, 3, and so on. So those are well-known, let's say, identity. And then the services were created. Note here for the headless service that we have created, a headless make it have a cluster IP of none. So we don't see here an IP for a private IP for that service. And then we have exposed our web application through a load balancer external IP right here. We'll go to see it later. And let's zoom out a little bit. And part of the deployment, we have already created a persistent volume. So we can see this persistent volume created in Azure or created in Kubernetes as a PVC, as a PV, and also as a PVC. If I go here to the Azure portal, if I go to the resource group where I have the managed resources like the load balancer and the VMSS and so on, and go to refresh, from here I will see 2 new resources created, the public IP address for my web application and also the PVC, the disk that were created to host my database right here. If I enter to that disk, I will see some tags created by AKS specific for that disk, specifying here the disk created for the pod and so on. And it shows me also that that disk was mounted to the VMSS first instance. So we have exposed publicly our web applications, so it will be accessible on this public IP. I'll copy it, and then I'll use it in my browser right here, and that will give me access to this .NET application, where here I can view some environment variables that I'm exposing from my application right here. So I see this is .NET 7 application deployed into Linux container and running on AKS, and the host name is this one right here. So this application is just for demo, and I want to access the stateful set database from this web app. So this is running inside the container inside the cluster, and from here if I click to products, I have actually added some code here to go to connect, to use that connection string from the deployment object to use it to connect to the SQL Server instance hosted in the stateful set. And here, yes, I can get access to that database, and they have also pre-populated that database with some data, so we can view those 2 rows coming from our database right here. So my application actually will use entity framework to also create the database if it doesn't exist. So it will connect to the stateful set, and through it will go to that Azure disk and create the database there. Okay. So the database is created. Let's go to check that actually. So from here, I'll go to use kube control exec, then the name of the pod for that stateful set. I'll connect to it, and then I will go to list the content of the var opt MS SQL data node that was actually the default folder where SQL Server will save the database. And yes, there we can find the database that we have created, which is productsdb.mdf. It was productsdb because inside the deployment object we have specified the database name to be productsdb. Great. Then next here I'll go to use an nginx container. So I'll create an nginx container, and then I'll go to update it, and I'll go to install the DNS utils. Oops, it seems I was too fast writing that. So I'll go to install. So I'm using here apt get install DNS utils. Let's accept that. Once these tools are installed, I'll go here actually to go to lookup into my SQL Server. So when I do here get services, I can see here the the MS SQL Server. And using nginx, I'll go to do ns lookup on that service name. So here I can see that service name, the complete service name, DNS name right here, it is available on the address 10.244.1.27. And this is not the IP address of this service, because that service actually doesn't have a cluster IP address. Okay, so that's, if we check here, kube control get pods-o wide right here to check the IP addresses of the pods. We can view here we have the pod stateful set is available on that specific IP address .127. So that's the IP address of my stateful set pod. So we have said that in a stateful set, each pod of the stateful sets, here I have only one single pod, it would have its own identity. So here I can go to do ns lookup into that specific pod, which is the pod IP. So I can use the pod name as an identity name for the DNS name right here. So I add that to my SQL service, which was the name of the exposed headless service. And that will give me the same result, so it will point to the same pod right here. So now for this stateful set, it have only one replica, but let's go to scale it to 3 replicas. So I'll go to scale my replica set to 3, and now if I do get sts, I will see here it's now the desired config is 3 replica. It will take few time before scaling to 3 replica. Let's give it that few time, and then next, if I go to get the stateful set, the pods, the services, and the PVCs, we can view that here new pods will be created. So this is creating that container, and as you see here, it will not start creating the 2 additional containers at the same time in parallel, like what will happen with the deployment object. Here it will create the second instance, wait until it's available, and then once it's available and ready to accept traffic, it will go to create the third instance, and so on. So it creates those instances sequentially. There are a configuration if you want to make it create those stateful set replica in parallel. So you can add that attribute into the YAML file for the stateful set. But the default behavior is sequential creation. Let's try again here. And yes, here I can view my 3 stateful set replica are now created. And as part of that also, it will create 2 additional persistent volumes and persistent volume claims that will be available right here for each one of these pods. That means if I go back to my Azure portal to the resource group, if I refresh here, I will see now I would have 3 disks for 3 Azure disks for those 3 replica. Each disk will be mounted into a specific pod of these 3 pods. Let's now check again the IP addresses of the pods. So I'll do get pods right here, -o wide, and from here I'll be able to see the 3 pods, and each one have its own IP address. Those 3 pods could be deployed into different nodes in my cluster. And then here, because we still have that service, that headless service, I'll go now to get the nginx. I'll go to nslookup for that service. For that, I'll use here the exec from that nginx, and then I will go to nslookup.msql service. And note here we have different behavior. Now we can see that each service would return a different IP address for the 3 pods, the 3 replica that they have created as part of that stateful set. So 27, 23, and 28. And as demoed before, we have said each pod of these stateful sets would have its own network identity. So from here, I can do something like this here, and let's look up for the DB stateful set for the instance number 0, and that will give me access to the IP address for that instance number 0. Note that here, that instance number 0 would have this IP address, which is the same one that we get right here out of the nslookup. So again, this is useful for multiple replica of the data. If I want to access first, second, or third replica, the primary, the secondary, the master, the slave, and so on. So this will be enabled, those scenarios will be enabled and facilitated using the stateful set in Kubernetes. And sure enough, you can imagine if I go here to request the stateful set number 1 right here, it will give me that IP address of the stateful set number 1, which is .23, exactly right here. And of course, for the instance number 2, .28, we can view that's the IP address for that instance .28. So now using this DNS name, I can access that specific pod. If I go back to my application, to that connection string that connects to that stateful set or to that database, note here in the server name, I'm using just MSSQL service. So this will give me access to always the first replica there. But I can add that domain name. But instead of MSSQL service, I can add the instance name of the pod, and that will give me access to the replica number 2 here, for example. Great, I hope this video was helpful for you. Thank you.